Well done to everyone for completing your criminological assessment last week. I'm going to talk you through the answers to the stats portion of this test. So first of all, you can see that I have highlighted the main things in the question that I think are going to be important. So I've highlighted the fact that they're looking to see whether people with smaller amygdala were more likely to behave in a violent or aggressive way. And I've also highlighted that they hypothesised that the group with the smaller amygdala would be involved in more violent or aggressive encounters with the avatars in the video simulation than would the group with normal-sized amygdala. So for question 1A, you are asked to write out a suitable operationalised experimental hypothesis for Dr. Dracup and her colleagues' study, and this is 3 marks. So a suitable operationalised experimental hypothesis for this study would be participants who have a smaller amygdala measured using an MRI scan will carry out significantly more aggressive acts measured by the number of times they chose to fight the avatar than those participants with normal-sized amygdala as measured by an MRI scan. You would get 1 mark for operationalising your independent variable, so that's people who have a smaller amygdala measured using an MRI scan and a normal-sized amygdala as measured by an MRI scan. You would get 1 mark for operationalising the dependent variable, so that's aggressive acts measured by the number of times they chose to fight the avatar. And you would get 1 mark for identifying that it is a one-tailed hypothesis, so you're saying they will carry out significantly more aggressive acts. And you know this because in the question it says that they hypothesised that the group with the smaller amygdala would be involved in more violent or aggressive encounters. Okay, and then we have our table of results. So this table is showing us the number of aggressive encounters during the video game of condition A and condition B. And what you are asked to do for question 1B is to work out the sum of the ranks for condition A and the sum of the ranks for condition B. Now, one of the main things to remember for a question like this, where you are asked to rank for 2 different conditions, is that you need to rank them first of all as if they are all in one list. So you're not ranking condition A 1 to 10 and then condition B 1 to 10, you're ranking them all 1 to 20. Okay, we rank smallest to largest. So we start with number 1, and there's only one number 1 in the list, so we can rank that as 1. Then we move up to 2, and you can see that we have got 4 2s. Okay, so what is sometimes helpful to do first of all is to rank them as 2, 3, 4, and 5. Okay, and then because they are the same number, they need to be ranked the same. So what you would do is find the midpoint between 2, 3, 4, and 5 and rank them all as that. So in that case, this becomes 3.5 and they all are ranked the same. If you find it helpful when doing a question like this, you can leave your initial ranks there just to give you a marker of where you're up to. Okay, so then we move on to the next score, so that would be 3, and we've got 2 3s. And because these were originally 2, 3, 4, and 5, we're starting at 6 now. Okay, so again, you could rank these first of all as 6 and 7, but you need to rank them the same. So again, you find the midpoint and you rank them both as 6.5. Okay, and then we move up to 4. So this one would be ranked as 8 because our ranks of 6 and 7 became 6.5, so we go straight up to 8. Then we have 5, and you can see you've got a 5 in condition A and a 5 in condition B. It doesn't matter that they're in different conditions, we're ranking them all as if they're one list. So 5 would be 9 and 10, so we rank them both as 9.5. Okay, and then we have 6 is our next one. So we rank that as 11. And then we have 7s. So we have got 3 7s. So we would originally rank those as 12, 13 and 14. But again, we need to find the midpoint. So in that case, they are just all 13. Then we have 1, 2, 3 8s. So we're going to start at 15 in this case. So this would be 16 and then this one would be 17. So again, we're finding the midpoint. We rank them all as 16. And then last of all, we have 3 9s. We're going to start ranking them at 18. So we call them 18, 19 and 20. And we would rank them all the same again because we have 3. Our midpoint is 19. So our final ranking for these is going to be 19. So that will mean although we have 20 scores, we don't actually have one ranked as 20, and that is fine. Okay, so then to find out the sum of rank A and the sum of rank B, we just need to add up these two columns, and this is where we start treating them as two separate conditions again. So for the sum of rank A, we're just adding up this column, and for the sum of rank B, we're just adding up this column. So our sum of rank A is going to be 56.5, and our sum of rank B is going to be 153.5. And that is your 2 marks there. So then for question 1C, you have to identify the statistical test you would use for this study and remember to justify your reasons in context. So this is 4 marks. So for those marks, you need to identify the test and then give 3 reasons as to why you know it is that test. So first of all, you need to identify your level of measurement. So we have ordinal data in this study, and this is because the score of the number of times participants got into a fight with the avatar can be ranked or ordered. You need to identify whether you are looking for a difference or a correlation. In this case, we're looking for a difference. And you know that because Dr. Dracup is looking for a difference between the 2 conditions, so small amygdala or normal sized amygdala, and whether one group engages in more aggressive acts towards the avatar than the other. You then need to identify whether your data is related or unrelated. In this case, it is unrelated because each participant is only in one condition. They either have a small amygdala or a normal sized amygdala. And then these 3 things tell you that you need to use a Mann-Whitney U. Okay, so this is the appropriate statistical test for this study. So then once we have worked out what our appropriate statistical test is, now comes the fun part and we have to calculate it. So you need to show your workings for this question. It's 6 marks and some of those marks will be for your workings. You have got the formulas to use. And for this question, for a Mann-Whitney U, you have to do 2 separate calculations. So you have one formula for condition A and one formula for condition B. Now these formulas might look a little bit daunting, particularly if stats is not your friend, but once you actually break them down, you can see that a lot of these letters can be replaced by numbers that we have actually already calculated. So for example, let's take the first letters, so UA and UB. This is what we're calculating. So this is our calculated value for condition A and for condition B. Then we have a lot of N's. So N is just the number of participants. So NA is the number of participants in condition A. So that's 10. And then NB is the number of participants in condition B. So that is also 10. Then we have the sum of rank A and the sum of rank B. So this is what we calculated earlier in our nice little table. So the sum of rank A is 56.5 and the sum of rank B is 153.5. So that means when you're starting to calculate your Mann-Whitney U, you can replace anything that's an NA or an NB with 10, and you can replace the sum of rank A with 56.5 and the sum of rank B with 153.5. So that all makes it a little bit more manageable. So then what you would need to do is rewrite out your formulas, but replace the letters with the numbers. So we've got NA times NB, so that's going to be 10 times 10. Add NA, so again 10, 10 plus 1, and that is all over 2. And then we're going to subtract the sum of rank A, so that is 56.5. Then we can just simplify that a little bit. Remember, you need to show your workings. So 10 times 10 becomes 100. We're then going to add 110 over 2. Take away 56.5. Okay, and it's 110 here because we've got 10 plus 1, which is 11, times 10, 110, and again, that's all over 2. So then we can add our 100 to our 110 divided by 2. So 110 divided by 2 is 55, so it's 100 plus 55. So we have 155, take away 56.5. So UA is 98.5. So that is your calculated value for condition A. Then we can move on to condition B. So again, we've got NA times NB, so that's 10 times 10, plus 10, 10 plus 1. This is all going to look very similar because the number of participants in both conditions is the same. And then we take away the sum of rank B, so that is 153.5. Again, we can simplify this, make sure you show your workings. $153.5. So this would be 155. Take away 153.5. So UB is going to be 1.5. And what you will need to remember for a Mann-Whitney U is that for your final calculated value, you select the smaller of the two values. So in this case, our calculated value is going to be 1.5. So now that we know that our calculated value is 1.5, because that's the smaller of the two, we can move on to what can you conclude about Dr. Dracup's findings, and you need to fill out the gaps in this bit of text. So your calculated value is 1.5, and then you need to say whether this is or isn't smaller than the critical value. So to do that, you need to know what the critical value is. And I'm sure you all found the formula and critical value table that is on Moodle. You need to find the section for Mann-Whitney U, and then you'll see there are a few different critical value tables for Mann-Whitney U with different criteria that you can see just at the top of the table here. And they're all just slightly different. We are going to be using this first one because we are using the 5% significance level, as you can see from the question. And we have a one-tailed hypothesis. So this is the one that we're using. So then to find the critical value in this table, you need to know the number of participants in each condition. So for both cases, that is 10. So we go down to 10 here, across to 10 here, and we find that our critical value is 27. So we can fill that in there. Number of participants for both conditions is 10. We're working at the 5% level of significance, and it's a one-tailed hypothesis. And then you have to say whether this means the results are significant or not. And you can find this by again going back to the critical values table to determine whether your calculated value has to be higher or lower than the critical value. So if we go right down to the bottom of all the Mann-Whitney U tables, you can see the calculated value must be equal to or less than the critical value in this table for significance to be shown. So our calculated value is lower than our critical value, therefore it is significant. So this means that the null hypothesis was rejected and the research hypothesis was accepted. So that part there would be 3 marks. It would be 1 mark for the correct calculated value of 1.5, 1 mark for the correct critical value of 27, and 1 mark for identifying that you are accepting the research hypothesis. So then your 4th mark is for explaining what this means in relation to your hypothesis. And remember, this has to be in context. So for example, you could say, this means that participants with a smaller amygdala engaged in more aggressive acts with the avatar than did participants with a normal-sized amygdala, suggesting that people with a smaller amygdala may commit more aggressive acts than people with a normal-sized amygdala. So that is the stats portion of this assessment. Make sure you understand it. If you went wrong anywhere, make sure you recognise why and how to fix it. If you're still unsure about anything, ask your lovely teacher and they will be happy to help you.